In this section, I'm going to have a look at how we're able to understand written language. In the simple cortical model, we could think about cortical areas with receptive fields at increasing complexity levels that discriminate between different types of visual situations. Then, reading the word dog could activate a cascade of receptive field detections in those visual areas, and the columns in the objects area could have recommendation strengths via an intermediate area in favor of indirect activation of columns that are often directly activated when looking at actual dogs, back into the same discriminates objects area. Now, that's certainly a useful way of thinking about reading, but there are some interesting things about a more detailed understanding. Remember, visual input is initially processed through area V1, and then onto V2, then the dorsal path through V3, and the ventral path through V4. The dorsal path detects receptive fields correlating with relative position, the ventral path with object type. And those are some of the typical receptive fields detected at different levels in the ventral path. However, in the case of visual images derived from a written language, there's a specific other area that plays an important role, called the visual word form area, VWFA. This area gets information from the ventral path, but also from the dorsal path. And it appears to get input directly from V1 and V2. This VWFA is the area that discriminates between different written words. If you can read English and see the word dog, there's a lot of activity in the VWFA. But there's also a lot of activity in V1 and V2. But if you know Chinese and see the Chinese character for dog, there's again lots of activity in the VWFA, but there's a lot more activity in V3 and V4 in the case of Chinese, indicating the more complex Chinese characters are handled using the V3 and V4 receptive fields that carry information about combinations and relative positions of the V1 and V2 fields, with the simpler alphabetic script just using those simpler V1 and V2 fields. And there's something else interesting about the VWFA. Remember how we talked about how face processing uses an area called the FFA, which is able to discriminate between large numbers of faces, which are very similar visual objects. Well, the FFA is a larger area that in illiterate humans includes the VWFA. But in humans who've learned to read, some of that FFA area has been taken over for the VWFA, which, if you think about it, makes sense. The set of visual words is a very large number of relatively similar visual objects, and all those objects must be accurately discriminated. They have very different behavioral implications, for example, much the same problem as discriminating between large numbers of relatively similar faces. So the area with receptive fields in a complexity range adequate for those type of discriminations is also needed for reading, just as it is also used for expert level bird discriminations and so on.